Here we go. Example 1, what we're going to do is you guys are going to go ahead and find all the solutions of tan x, cosine x, minus cosine x on the interval from 0 to 2 pi. So what it means by 0 to 2 pi is you guys are going to be looking at, only one rotation on the unit circle. If you remember, the unit circle goes from 0 to 2 pi. All right, that's what one rotation comes from. Now, if I don't have it listed and it just says all answers, that means it goes on forever and ever. So what you're going to do is you're going to add 2 pi r onto the back of your answers. So we will get to a problem that looks like that in the next video. But for this one, let's go ahead and solve it. So we start with tan x cosine x minus cosine x equals 0. Imagine these to be polynomials. When you need to find polynomials, your first step is to factor. The first thing I can see that factors out is a cosine. So I pull a cosine x out. I'm left with tan x minus 1 equals 0. From there, we're going to use the zero product property. Set each factor equals 0. So cosine x equals 0, and tan x minus 1 equals 0, which means that tan x equals 1. Now that I get to this point, I need to go into my unit circle, find where cosine has a value of 0 and where tangent has a value of 1. When I go through and look in there, I see that cosine x is 0 at pi over 2 and 3 pi over 2. Then I see that tangent is 1 at x equals pi over 4 and 5 pi over 4. So what I see that when I'm looking at this is that at pi over 2 and 3 pi over 2, my tangent is actually undefined. So it is impossible for these answers to hold true because, yes, it fits for cosine, but if I multiply that by tangent, it's going to be undefined. So these are going to be my only answers, and those cannot be the answers. So there's a little bit of logic behind it. So that's going to be how I write my answer. And I don't need to add anything else to it because we're only looking at one rotation. So we're going to hop into another problem that's going to include more rotations.